Hi everyone, welcome back to Caesar Education. So in this video we are going to talk about scalar and vector. So let's start off with a scale. A scalar it's any positive or negative physical quantity that can be specified by its magnitude. So when I say it can be specified by its magnitude, I mean that we can measure the size of this quantity and we can present it just using its magnitude. Here, let's say you have a line and then I measure the length of this line and I found out that I have 2 centimeters. Now this length, it's a physical quantity of this line, and here we have specified it using its length, its physical quantity length, and we represented it using a magnitude. So any physical quantity that can be represented using its magnitude, we call that a scalar. All examples of scalar can be the length, just like I showed you here, or it can be the mass. So when you go and buy your carton of milk and you find out that your carton of milk is 1 liter, which is usually weighing has the mass of 1 kg. That physical quantity of that carton of milk, which is its mass, can be presented using its magnitude. Therefore, that makes mass it a scalar quantity. Now, a lot of people, when they talk about how much they weigh, they will represent it in kilograms. And when you talk about something's weight, you are talking about taking the mass of something and then the force that the gravity exerts on that mass, a force that the gravity exerts on that mass, pulling it down, that is called its weight. But once you talk about it is pulling it in a certain direction, then you are talking about a vector quantity. Now, a scalar quantity, we said it's a positive or negative physical quantity that can be presented using its magnitude. You see, with mass, a mass is just a body's composition, and something can have a mass of 1 kg. But once you exert a force on that mass in a certain direction, then it turns into a vector. So we can explain this concept basically by comparison and saying, okay, a scalar quantity is a physical quantity that you can represent using its magnitude, but a vector quantity can be represented using not only the magnitude but also direction. So let's go back and compare mass and weight. So mass is a body's composition. So something will have a mass of 1 kg, but so it only has magnitude, just 1 kg. There's no direction to 1 kg. It just has a mass of 1 kg. But once there's a gravitational pull on that mass, the force that the gravity pulls down a certain object's mass, then it turns into weight. And now there's not only the magnitude, but there's now a direction that that weight, the force, is acting in. So once you have a magnitude, maybe 2 kilonewtons downwards, then you know that, okay, now I have magnitude and I have direction. And that is the main difference between scalar and a vector. And their definition is basically in their comparison, that one is just magnitude and the other has magnitude and direction. This weight of force, this direction that is acting on, we call it a line of of action. So this direction that it's acting on, we call it a line of action. So I'm not saying a vector is magnitude and a line of direction, but I'm saying it has a magnitude and a direction, and then that direction it's following the line of action. So if you have a box and you start to push that box with a certain force F, that force will have a magnitude, a certain magnitude, let's say 2 kilonewtons, acting to the right. The direction is to the right. Let's say your right is positive. Now, this direction that it's acting upon, that it follows a line of action. Other forces that may be acting on that box could be, you can also have the weight, it's being pulled down by weight. The line of action will be in the y-axis. You could also have some sort of, if it's on the table, there will be friction here, and friction opposes motion, so it will act in this direction. So they will have magnitude and direction and a line of action. So that is how you define vector and a scalar quantity. Now, as to how you represent them, if you are reading on a textbook or something, a scalar quantity, we can just say, let's look at examples and see how we represent it when we write it down. Let's say we are looking at a force. We say it has a magnitude and direction. You have to be pushing in a certain direction, and you have to be pushing by a certain amount of force. You can also have velocity, when you are moving at a certain speed in a certain direction. So remember, a vector must have direction. So speed, let's add speed here. Speed is a scalar quantity because it has a magnitude, only a magnitude. You can say something is moving at 5 kilometers per hour, but once you say it's moving at 5 kilometers per hour in a certain direction, then speed becomes velocity. Now, we are going to represent them as a vector quantity by putting an arrow on top of the variable that represents your quantity. So force is represented with an F. So to show that we are talking about a vector quantity and not a scalar quantity, we are going to put an arrow on top. Just like velocity, we'll say V and then put an arrow on top. But if it was a scalar, I would have just written F and it would give me just magnitude. So here our length will just be L, our mass will just be M, our speed will just be S. However, if you are dealing with a vector, you put an arrow on top to show that it has magnitude and it has direction.